Hi, good morning. Thank you for joining me here in my shop. It's July 26th. The sun is shining. I should be outside. What am I doing in here? You know, I'm kind of hooked on this kind of stuff, so that's why I'm in here. The next step with this radio, I think, is because this information is available, will be to just check through the high voltage voltages in the radio, like the plate voltage and the screen voltage on the tubes, and see if it matches what the schematic suggests should be there. And maybe we'll find some further defect in that doing that, or find something that's out of whack. So let's take a look at the schematic here. Okay, so the voltages are just written right on the schematic, like here it says 100 volts right here for the plate of the 12BE6, 100 volts, 50 volts. So the numbers are here. There's right on the this line here, 100 volts right here. So using that as a guide, and with a radio like this, the voltages are low anyway. Like it might have a slightly higher voltage on the plate here, like 115, and then a lower voltage on these guys, maybe 80, 90. In this case, it's 100. And then this plate usually has a reduced voltage on it, the detector plate, and sure enough, 50 volts. So you don't even really have to look at this to find it. Look at this. What are they saying here? 100. Oh, that's the rating. That's the rating. 120 volts, right on the. So 120 volts, and we're losing 5 volts in this coil here, I believe is what's happening. Okay, that's good. Good. Okay, just about ready to start. I think what I'm going to do is I'm not going to study the schematic and figure all that. I'm just going to go around the different tube pins, and I'll know it when I hit it. But the set's not on right now. I'm just going to practice a little bit. Not that it takes much practice, but I just want to, before the set is turned on. 1, 2, 3, 4, 5. Yeah, I can get it all of them, I'm pretty sure. All the tubes. Okay, let's switch on here. In case I appear to be very short, suddenly I am. I'm down on my hands and knees here. Well, I'm down on my knees actually. My hands are up here, as you can see. So a good thing to do would be look at the B plus voltage first. Operating. There's no, yeah, there is an antenna. The antenna is switched off. No, there's no antenna. I have it connected to a signal generator that's not turned on. Fine. Okay, B plus, looking at the meter over here. Ooh. What have I got this set to? 150 volts full scale. 75 volts. Let's look at the other high voltage terminal. That's a little better. It's 110. Good. That's good. We'll just pick any tube. We'll start here. I don't know which one is the high voltage terminal, so there we are. So there it is. Just under 90. I think that's good. I don't know, does this tube have a screen? I don't even know what tube I'm doing here. Well, that's kind of crazy. If you don't know what tube you're doing, then there could be a screen voltage missing and you wouldn't know it. Except the radio wouldn't work, pretty sure. Maybe I'm going to have to do that. There we are. That's ground. That's 2 tubes. This one here, which I'm having a hard time seeing because of the light. Okay, we'll start right here. I think that's ground. Here it is. No? Where's the high voltage? Scare myself. There we are. Ooh, that's not very high. This is probably the detector tube, and that's 40 volts. That's a little low, isn't it? 60? 40, and we've got 108 volts on the radio. Let me just put it up a little bit higher. 117 volts, that's more appropriate. 40 volts there. 40 volts on that too. This is the output tube here, I think. 120 volts on the plate. That's probably the plate. That's probably the screen. That's good. Very good. Now, I'm going to assume this is the grid blocking capacitor here. We're going to look at the voltage here. It appears to be nothing. Let's make this meter very sensitive. So if this is the grid, we're going to have to check this out. We're looking at about not just under a volt positive voltage sitting on it. The cathode is this guy here, and he's got a lot more positive voltage on it. Okay, so that's 8 volts. That sounds correct, but this negative voltage shouldn't be there on the grid. Let's go back and take a look at that again. Positive voltage on the grid. Sorry, wrong. I said the wrong thing there. It's going up. Look, see it? Can you see the meters just going up and up and up? So that's a leaky capacitor there. That implicates all three of these blue capacitors. Okay, story's got a little more complicated here. Unexpected situation. I kind of figured those blue capacitors would be, thumbs up. Apparently not. Something special about those capacitors? I'm going to nip this one right out right now without even checking the schematic. I'm going to nip them out. Let me just pull the plug out of there. And put in a clip lead to market. So how high would the voltage go? Well, who knows? Could go all the way up to the available value on the other side of the capacitor, and that might be 40 volts. Yikes! That might be a big problem. Okay, let's just put this right here before I lose track. What is with this capacitor? Nice looking blue one, 0.01, 600 volts. Got the lead a little short here. Let's start with this tester. Now, what if there's a leak? If this is a leaky capacitor, this tester will tend to read its capacitance high. Stay on there. What do you say? 12 nanofarads. Well, that's not very good. 12 nanofarads. That would be thinking hard now. 0.01. That'd be 0.01. 0.012, and this is supposed to be 0.01. Okay. So you wouldn't be too suspicious from that test. But let's put it on the big leak test. Let's stress them out here. So this guy's going to throw some voltage across this capacitor and then detect any current that's leaking through it. A perfectly good capacitor, it won't detect any current. It's too small. It's virtually nothing. But on an old capacitor, there tends to be a leak. So now, if you haven't seen this being done before, you're trying to keep an eye on this. Can you see there's a pie shape at the bottom here? It's a little hard to see from the lighting. That pie is what you want to watch. So I'm going to hit the switch here. It's going to put 50 volts on the capacitor. Current is going to go into the capacitor. Capacitor is going to charge. Current's going to stop. Or is it going to stop? If the current stops totally, the eye will come open like this. But if there's a leak, the eye will stay closed or partially closed. And here we go. Right open. Oh, it's a high voltage capacitor. Let's go 150. Right open. Let's go 250. Pretty much open. So I don't think this guy, wow, that's not much of a leak. That's not much. That's not much. Brand new capacitor. We'll go right to the top here. 450 volts, 0 leak indicated. So it's leaking a little bit. It's in a very critical spot. Typically, when I'm pulling capacitors out of old radios, they're wax capacitors, and they leak really badly. And that first voltage test, 50 volts, the eye would close and never open again. That's more typical. So this is interesting. This is a half-baked, half-leaky capacitor. I'm going to put a new one in there. We'll see if that positive voltage on the grid disappears. Now, I've had experiences in the past where doing this actually doesn't clear the positive voltage. I have no idea where it comes from in those cases, but we'll give it a try here. So 0.01 capacitor goes in and we'll see what happens. Okay, new capacitor is in. Let's turn this set on. So hopefully what this has done is it will stop the grid of the output tube from drifting positive from a leak coming through that capacitor. Now, almost certainly the person who replaced the capacitor, the original one, which is almost certainly a wax one, did it for exactly the same reason I just did it now. It's just oddly enough, I just would have thought these more modern capacitors would still be good. But now, prepare to get egg upon your face, Jim. So we're on the 5 volt scale. Positive will push the meter. Oh, you can't even see the meter. Oh, that would have been disappointing. So first I'm going to go on the high side of the capacitor and find out what voltage is there anyway. So we'll go there. Noisy guy. So that's the 50 volt scale. That's about 40 volts. And on the other side, 1.5 volt scale. So my meter is 0. What's going on here? I'm not sure why my meter is flailing around in the air here. A little off 0. That's kind of odd. Something to do with putting it on the lowest scale. Okay, let's look now. See it go up just a wee bit? A wee little bit. So that's a small part of 1.5 volts. And I don't think you can get rid of that. But a far cry from the voltage that was building up on it. And this voltage won't build up. It won't go up. It's just going to sit there like that. It is going up. It's going up very, very, very slowly. Okay. That's not supposed to happen. Now, there should be a resistor. Let's look at the circuit. There should be a resistor bleeding down the any voltage that built. It should be. Let's take a look at the schematic here. Okay, so the part we're interested in is the output, and we're looking at this grid. This is the capacitor I just changed right here. Let me zoom in a bit. So this is the capacitor I just changed. This is the my mouse has stalled again. I don't know what it is that goes on in here, but oh, now it's flying. Here we go. I have terrible time controlling the mouse in my shop here from some kind of interference that's occurring. So there's supposed to be 60, I thought here. 50. Okay, 50 volts here. I'm measuring 40 here. And then on this side, we were measuring a tiny voltage which was going up. And my guess is it might have gone all the way up pretty close to 40. This resistor should be bleeding off any small charge that's developing here. What's going on with this resistor? R18 470K. Shouldn't be anything going on. It's not exactly got a hard job to do here. And by that I mean it doesn't conduct a lot of current. It doesn't get warm. Come on, mouse. There we go. Let's check out that resistor and see what's happening. So there should be a resistor connected to that terminal. And I didn't see any resistor there. I got this totally wrong. There's there's nothing there. There's just a capacitor going there. There's no resistor. Am I not on the right thing here? It's pin 2. What's it show on the schematic here again? Does it give pin numbers? Yes, it does. So we're looking for the grid pin 2. Pin 2 or 8. Looks like or 5. I mean, I can't read the numbers. Pin 2 there though. This resistor does not appear to be in the radio. Come on. Anytime I find something like this, I kind of scratch my head and go, what stupid thing are you doing, Jim? The only other capacitor that's connected is over here. Maybe I picked the wrong capacitor? This is on pin 1. No way. No way, because I measured the voltage here, 40. This is missing. Come on. It can't be missing. Okay, let's look back at the radio and look closely at it. Here's a certain amount of frustration or anxiety. I don't know what it is that's developing in me here. When I sense I'm getting a little bit emotional, I tend to stop work. Don't like to get be upset and do this stuff. That's a big mistake. Well, let's. The set is operating, so. Oh my gosh. Yeah, let's turn it off. Okay, I can always turn it back on. I can't unelectrocute myself though. We'll take the close-up camera here, and we're going to look at that really closely because maybe I just haven't seen. Like sometimes it's very hard to see the detail in here. So, well, there it is right there. It happens to be looking right at it. Okay, so you can see the capacitor, and maybe there is something in there. Let me get a poker. I don't think so. Let me turn on the blaster lights here. I keep my shop lights quite low all the time, but I think it makes a better video image. Maybe I'm wrong about that. It makes a terrible image on the back of my eye. So now I have the light on. So we see this capacitor coming here. And we see this resistor. This is the cathode resistor. It's brown, green, brown, and it's tied to this terminal. And there's a green wire here, and that's coming from this bypass capacitor over here. And the green wire goes past and it ties to the cathode, of course. So there's nothing in here. Oh, they put it up here. Well, no. You can't have it over here. You can't. What's this one? This is something else. It's like a plate resistor or something. Come on, really? A missing part? Right from the factory? Come on. I, I don't believe it. I don't believe it. So I'm going to go drink some coffee and come back and reconsider the situation here. Holy smokes, I don't know what to think. Yeah, I'm beside myself. Well, the coffee cup has revealed the situation here. So the coffee cup said to me, Jim, didn't you say there were two terminals tied together for the grid connection on that radio? He says very slowly, yeah, this pin or this pin. Both these pins are tied to the grid. They're the same thing. And down here, can you see it? Can you see him? He's hiding. He's hiding under here. There he is. There's the resistor. And it's going right over to the ground terminal over here. So that's it. There it is. Thing solved. Okay. Yes, they did not forget to put in a resistor. Now the question is, how come we're building up a voltage there and it's climbing? I mean, you think, okay, things are going to settle in at some kind of stable situation where the current leaking through this resistor is sufficient to draw down the voltage from the grid, and it'll stabilize at some very low amount, maybe even so low you can't even read it. On a meter, not in this case, you can read it. Let's check that resistor there for its resistance. That's what we got to do here. Now, resistors tend to go up, in my book anyway. They tend to go up, not down. And that was supposed to be a half a million ohms. Are you really? Half a million ohms? Are you really? Okay, so we're going to go from that pin to here. Half a million ohms. So the next thing would be to reason out that a small leak will cause a small voltage to develop, and the voltage is not enough to worry about because the cathode voltage and the bias voltage up around 8 volts. So if this goes up, a fraction of a volt, so we're a fraction less than 8 volts on the bias, that's nothing to worry about. I think the name of the game here is to operate this radio for a fair period of time and then check that voltage. And the meter I've been using, this guy over here, may not be quite good enough for it. It may draw down the charge fast enough that we really can't get an impression of the voltage that's there. So what that would look like is you touch the lead, and the meter will go like this. You have no idea how high it was going to go because it's bled away the charge. But to enable this, I have another meter. I have this guy over here, which we will use. This one takes quite a while to settle down, so I'm going to turn it on now. This guy's input impedance is more than 10 times the other meter, which is a really high input impedance meter. So this is 120 mega ohm input meter. Input Peter. Yeah, I'm talking fast. So we'll let that guy warm up. Then we will repeat the voltage test, and I think we're going to reach the conclusion I just said, that you can't completely stop the leak. Still strange, because in my experience, this kind of arrangement, you get a 0 volts on the grid there. You just can't build up a voltage against that resistor. I don't know. Let's see what happens. So we're going to try 2 tests here, both the same thing more or less. I'm going to have the meter hooked up when I turn on the radio, and we'll watch for a voltage rise here. This guy, oh, it's positive, isn't it? Yes, it's a positive voltage rise. This is a 1 volt scale, so it won't take long for this to get all the way up. So I'm going to have it connected right from the start, and then we're going to fire up the radio. Hopefully not have it catch fire. Here we go. The roar you're hearing, that you may have noticed in the background, is the air conditioner in my house. Right? So So here we go. Okay, first she's on. You have the light bulb unscrewed in case you're wondering why the light bulb didn't come on. Everything's normal, so we're going to give it 117 volts. What happened there? It went up. It went back down. That's curious, eh? Don't you wonder what that might be? Now the set is on. Okay, and there's absolutely no voltage developing. That's curious. I mean, this is what I would expect. You know, I've put the clip lead here on the terminal that has the resistor on it. Now, it shouldn't be any different than the other terminal. Let us look and see. No, it shouldn't be any different. Well, that's curious. How come I measured a voltage with the other meter? Let's just double check. Nothing happening at all. It's a 0. It's like it's supposed to be. Wow, this is kind of disappointing. Yeah. Oh, you know what? Bad clip lead. Yes. So I've discovered the way I've been testing my clip leads may not be effective, and I may have a number of defective clip leads in my collection of clip leads that I think are good when they're not. Let's find out. So it's just an ohm meter. Well, it looks pretty good. I don't see a problem with that. Yeah. No problem with the clip lead. Gee, what about the white one? What about this one? Pretty sure it's good. Okay, clipping into a live radio. Hey, we got a reading. And it's going up. What's different? I think somehow the connection didn't make in here. Somehow. I don't know how. So here we are. Now we're going somewhere. Not really where we want to go. That's 1 volt. This is the 3 volt scale. This just see where it gets to. This is really surprising to me. Yeah, 1 volt across 500,000 ohms. What's that give you current wise? This is still climbing. Okay, so we're going to let this go for a while. I have other things to do, and then I will come back and we'll see what has happened here. Okay, now it's long enough to be outside. Wow, what a beautiful day. Just fantastic. Well, look where it is. So it's at the top of the scale here, and it's still climbing very, very slowly. So it's 3 volts now. So if the bias is 8, and what is the bias? What's the ideal bias here on that tube? 50 C5. What do they recommend here? Class A operation. Grid number 2. Grid number 2. Where's grid number 1? Typical operation. This is really what I want. Anyway, grid number 1, minus 7.5 volts. So I saw minus 8 on the cathode resistor. So, you know, maybe they've made an allowance for this. This is now above 3. That's on the 10 volt scale. So 3 volts. Looks like it's stabilizing at 3. 3 minus 8 is 5. 5 is quite a ways below. Is this a problem? Is this a problem? Maybe I can ask it another way. Is this a problem? Why don't we do a little experiment here while we're pondering things. I'm going to turn on the other meter, and what I'm going to do is I'm simply going to contact here, and what I'm interested in is what happens on this meter. Does this meter with its 10 megohm input, I'm pretty sure, is that interfering with the charge that's here? It's just kind of finding out about that meter versus this one. So watch this meter. There we go. Just better make sure this is up. Okay, here we go. What's it do? Now, did you see the drop? You may not have seen it from that distance. And right back up again. That's interesting. Right back up to the just a hair over 3 volts. And why don't we let's just compare meters. Put this on positive, and it's off 0 again. And we're looking at 3 volts. This is 5 volts full scale here. So on this other meter it's 3 volts exactly. When I do that, we can read on the 5 volt scale it's 3.3 on that meter. On the other meter here it's 2.9. Wow, that's quite a difference in the two meter readings. 0 is good. And what about now the 0 on this other meter drifts. It drifts for a long time. Like it takes a long time for this. So maybe the 0's drifted off. Yes, it has drifted off. A little bit. Let's just get it right. Okay. Now if we put this on, now we're reading just over 3. That would be 3.2. 3.2. I'm doing a little meter check here. 3.2. What do you say? And it says 3.4 or so. But in fact the voltage dropped just a bit when I put it on here. Now that's interesting in itself. I would have thought the situation is you can't restore the charge quickly. That's creating the voltage. It has to leak slowly through the capacitor. So if you bleed away some of the charge by putting a meter on, when you take it off, this should come up slowly. But it came up fairly quick. That tells me there's something on the grid pushing it. The grid itself. So, it could be things like a leak inside the tube. You could have like a leak of charge, I suppose, from the plate to the grid. I'm sure they do everything they can to make sure that kind of stuff doesn't happen, but everything is happening to some degree all the time, everywhere. So, now, again, is this really a problem? I think it's very undesirable. I think this is bad news. When I checked the output tube, what did I find? I can't remember. So, this is an interesting thing. I think I want to pursue this for a little bit. Where's this voltage coming from? That's basically the question. Where could this voltage be coming from? And it's either coming from the supply, the 40 volt plate supply leaking through the capacitor, or it's coming out of the tube itself. The tube grid is somehow involved in this. Now there is a thing called grid biasing, where the grid will become negative to the cathode on its own under the right circumstances. And a lot of radios make use of this to generate the necessary bias without any other effort. The tube will self-bias. That's the term they like to use on it. But this voltage is going positive. The self-biasing thing will drive itself negative. Don't understand what's happening here. So I think it warrants more experimenting. It's a good opportunity here. I'm gonna try a few different output tubes and see if this effect comes and goes with it, and maybe we'll learn something. And you know what? That's gonna be for tomorrow, because it is so nice outside. I can't stand it. I gotta get out there. My cat is wondering why am I in the house. Yeah, so we'll do that. We'll experiment with this situation a little further, because I think it's unusual. And I'm a curious guy, and I think you are too. So tomorrow we'll try to satisfy our curiosity on this. Thanks a lot for watching, and hope you enjoy your day. See ya.